Hello, this is your test 3 review. For your test 3, we're going to be going over chapter 6 and chapter 7. Let's begin with chapter 6. For chapter 6, we're working with confidence intervals. So that's given some value, let's say some mean. You want to find the possible smallest number we can work with or biggest number we can work with some level of confidence. In chapter 6, we'll also do the same thing but with a proportion, a percent, some p-value. All right, let's continue with 6.1. Confidence interval for the mean with sigma known. Now, just to emphasize, sigma is your population standard deviation, and that's what makes this section unique. So if you're given the symbol or you're told that you have the population standard deviation and you're being asked to work with a confidence interval, this is the type of problem that you'll be working with. Now this problem reads, for a random sample of 24 months from January 2006 through December 2016, the mean number of tornadoes per month in the United States was 100. Assume the population standard deviation. Population standard deviation is 114. Construct a 90% confidence interval for the population mean. Okay, so for this type of problem, you're going to, we'll use our calculator for all of them. For this one, you want to go ahead and press stat. Make sure you scroll to the right so that test is highlighted. And when you have a confidence interval with a population standard deviation, you're going to scroll down and choose Z interval. Now in my calculator, it's option number 7, so I can just press the number 7 to choose Z interval. From here, we're going to need these pieces of information. We're going to need our standard deviation, population standard deviation, our mean, our x bar, our sample size n, and our confidence of level of confidence. All right, so for this problem, we have a population standard deviation of 114. And we said there was a mean of 100 tornadoes, that's our x bar. And lastly, we have a sample of 24 months. So let's fill that out. So we have a sigma of 114, x bar of 100, n is 24, confidence level of 90. All right, punch that into our calculator, and our calculator is going to give us this answer. 61.724 and 138.28. So what does this mean? This means that with 90% confidence, my lowest number with 90% confidence is 61.7, and our highest number with 90% confidence is 138.28. We round up to 0.3. Our answer, it does say to round to the nearest whole number, so our answer would be, rounded up, that would be 62. Rounding, this would be 138. So our answer would be 62 to 138. That's what we're looking for. All right, that's a 6.1 problem. Let's move on to 6.2. Confidence intervals for the mean. What's different here is that your sigma is unknown. So what makes this different is don't expect the word population standard deviation. You're only going to have standard deviation, and that's important. That's what makes this section unique. All right, let's read our question. Assume the population is normally distributed and use the t-distribution to find the margin of error and construct a 95% confidence interval for the population mean. All right, let's do our problem. In a random sample size of 8 people, the mean commute to work is 35.5 minutes and the standard deviation of 7.2. All right, notice there was the word population. So this is how we know it's a 6.2 type of problem. All right, we're going to use our calculator to find our confidence interval. We're going to go ahead, use our calculator, and we're going to press the stat button. Once we're there, we're going to scroll over to our third option test. For this problem, we're going to use a command called t-interval. Now in my calculator, this is option 8, so I can go ahead and just push number 8 to choose t-interval. From there, we have to fill out these pieces of information. We have to fill out what is our x-bar, our mean, our standard deviation, our sample size, and our confidence level interval. All right, so here we're given a mean of 35.5, a standard deviation of 7.2, and we have a sample size of 8 people with a 95% confidence. All right, our calculator will now give us an answer, and remember, we interpret this to be the highest and smallest number with a 95% confidence. So it gives us 29.481 and 41.519. It didn't tell us how much to round, but we can round to maybe 1 decimal place. So our answer would be 29.5 and 41.5. This would be our answer with 95% confidence. All right, last for chapter 6, 6.3, confidence intervals for population proportions. What makes this section unique is you'll be given maybe a value or a mean in terms of percents, and percents a proportion. It's a percent. And that's the big clue for this one. So our question reads, in a survey of 1,000 US adults, 700 think police officers should be required to wear body cameras while on duty. Construct a 99% confidence interval for the population proportion. Round to 3 decimal places. Okay, so for this one, when we're working with confidence intervals and proportions, our calculator command is stat, then test. As always, press the stat button, scroll to the right to the third option so that test is highlighted, and then you want to choose, scroll down until you choose 1 prop z int. There's another one that looks like this, but make sure it ends with int. Now, my calculator makes this option A. So if you want to use a shortcut, you can press the green alpha button and then A. Okay, for this one, we have to fill out these pieces of information. We have to find X and NC level. And once you go onto your calculator, it tells you this. So you don't have to remember this. You just need to know how to read that and interpret your question. All right, so for these type of problems, we're given a value to work with, a p hat. A p hat is always x over n. In this case, so x is the number of successes, n is your sample. So we have 700 out of 1,000. So we have 700 out of 1,000, and we punch that into our calculator. We're working with a confidence interval of 0.7. And I want to find my lowest and highest number with, in this case, a 99% confidence. All right, so the reason why I like to do this is because it sets you up so that you directly know which one is your X and which one is your N. All right, so X we said is 700, N is 1,000. your confidence level, 99, so we're at 0.99. You press calculate at the bottom, and your answer in your calculator is 0.662 and 0.737. Actually, I think it's a bit more. I'm giving you the answer. Your calculator, since I did say calculator, your calculator will give you 0.66267 and 0.73733. Because we want to round to 3 decimal places, you look at the third option, and if the next number is 5 or bigger, you move up. So that should have been a 3. And if the one number next to it is 4 and below, it stays. So that's why it's 73.7. And this is our answer. All right, we're going to go on to chapter 7, hypothesis testing. So for hypothesis testing, the idea of this is you're being told some fact and you want to test it to make sure it's true or not. Well, to make sure whether you believe it or not. I think that's a better choice of words. So for these type of problems, we're trying to work with some confidence, and we're trying to determine whether we want to accept their claim or reject it, or fail to reject and reject. Instead of drawing a bell-shaped curve every time and seeing whether you fall in your reject region or your pass region, I really do prefer the inequality because it saves the possibility of making a slight error in your interpretation. So for your hypothesis test, have these in mind. We have 2 options. We're going to compare it from our answer, our P, to our confidence interval, our alpha. If it's less than or equal to, we're going to reject your null hypothesis. Our second option, if P is greater than your alpha, you're going to fail to reject. And those are our only options. Yeah, and we're going to be using those 2 inequalities, so have them handy. All right, just like confidence interval, we're going to have those same types of problems, but using hypothesis testing. Let's go ahead and do that 7.2 problem. A manufacturer of sprinkler systems designed for fire protection claims that the average activating temperature is at least 135 degrees Fahrenheit. To test this claim, you randomly select a sample of 32 systems and find the mean activation temperature to be 133 degrees Fahrenheit. Assume the population standard deviation is 3.3 degrees Fahrenheit at alpha equals 0.10. Do you have enough evidence to reject the manufacturer's claim? All right, for these type of problems, hypothesis tests, you must start off by saying what your claim is. And from your claim, directly from your claim, you're supposed to see what your null and alternative are. So your null is your ho, alternative is your ha. All right, our claim says that the average activating temperature is at least 135. At least produces an inequality of greater than or equal to. So our claim is our mean temperature is greater than or equal to 135. Our claim has that equality, and remember your null always has equality. It's going to have an equal to, greater than or equal to, or less than or equal to. Your ha, your alternative, it's going to have a not equal to, greater than or less than, but no equal to. So our claim says greater than or equal to, so that strictly produces your null. So we have a mean that's greater than or equal to 135, and therefore our alternative, our ha, is a mean that's less than 135. So if you look at your inequality, it switches. And that's how you produce your null and alternative claims. All right, let me erase that. All right, from there, we're going to use our calculator to find our answer. For our calculator, we're going to go ahead and press Stat and scroll to Test again. And our option for this type of problem is Z-test. So we're going to scroll down and choose Z-test. On my calculator, that's the number 1 option, the first one, so I can just press 1 to choose Z-test. Or I can scroll down and choose Z-test. All right, we need to fill out our mean, our standard deviation, our mean from our tests, and our sample size from our tests. All right, our mean from our claim is 135. Our given standard deviation is 3.3, and the reason for my delay is because I wanted to highlight for you the word population. That's what makes it this type of problem. All right, so 3.3, and X bar is 135. My sample size is 32, and that's from our problem. Last piece, we have to say what kind of tail test it is. Our option is right-tailed, left-tailed, or two-tailed. Always look at your HA to know what kind of tail you have. Because it's pointing to the left, we have a left tail. So we want to choose your option that looks like this. Less than a mu naught. All right. It'll give us some information, but we want to use our P because we want to compare our P value to our alpha. It gives us a P of 0.0030, another 0.03. Your goal is to compare your P and your alpha and see what inequality you get. My P is 0.0003. My alpha is 0.10. So now I want to choose an inequality that makes that statement true. And we have a less than. Because we have a less than, our answer is to reject the null. Now, I do have a note here before I move forward. I say that P appears in the calculator, and it writes it in scientific notation. So what you do is you move the decimal place to the left 4 places. That's why it's a negative. The -4, you have to move it to the left 4 places. And if we do, that's how we result in this 0.0003. All right, 7.3 problem, hypothesis test with sigma unknown. So again, we're going to be given a standard deviation, but it will not be a population standard deviation. Let's read our problem. A used car dealer says that the mean price of a 3-year-old sport utility vehicle in good condition is $20,000. You suspect this claim is incorrect and find that a random sample of 22 similar vehicles has a mean price of $20,640. A standard deviation of with a standard deviation of 1,990, is there enough evidence to reject the claim at a confidence of 0.05? All right, now I wrote an X there because notice there's no population standard deviation. So we're given our sample standard deviation, and that's what makes this type of question unique. All right, we're going to use a calculator for this type of problem, but whenever we're working with a hypothesis test, we have to make sure to state our claim, our null, and our alternative hypothesis. Our claim is that first sentence says a used car dealer says that the mean price of a 3-year-old sports utility vehicle is $20,000. All right, so it's not saying less than, greater than, at most, at least. It's saying is, and that means equality. So our mean is 20,000. Therefore, my null has the equal sign, so it's going to be the same, 20,000, and my alternative, my ha, mean is not equal to 20,000. All right, let's go ahead and use our calculator. So we're going to press stat, the stat button, scroll, make sure test is highlighted like before, and here I want to choose the second option. I believe it's t-test. I don't think I wrote it correctly on my notes. So second option. I'm iffy about that one because I don't think I wrote it correctly on my notes. All right. I have a mean of 20,000, an X bar of 20,640, a sample standard deviation of 1,990, and then we're going to choose an option for our test, and you always look at your HA for your test option, and it's not equal to your mean. It's a two-tailed test. So this gives us our p-value. Your calculator tells you have a p of 0.146. 3314799. That's too many numbers. Let's round to 2 decimal places. So I have a p of 0.15. Let's compare our p to our alpha. So we have a p of 15 and an alpha of 0.05. What inequality makes this statement true? A greater than? Because it's greater than, our answer is fail to reject that null. All right, so 7.2 was with the population standard deviation. 7.3 was for a sample standard deviation. 7.4 would be with proportions, similar to our confidence intervals. Okay. Seven point four, our question reads, a researcher claims that 85% of Americans think they are unlikely to contract the Zika virus. In a random sample of 250 Americans, 225 think they are unlikely to contract the Zika virus. At a 0.005, is there enough evidence to reject the researcher's claim? All right, so just like before, we need to state the claim, and from there create a null and a alternative. All right, the claim says that 85% think it's unlikely, so it's not equal to. So it's not equal to that 85%. This claim gives us our alternative because it's not equal to, so we have a mean not equal to 85, and therefore our alternative is equal to 85. Okay, to know whether we accept or reject our null, we're going to use a calculator. So we press stat, scroll over to test, and we want to choose one prop z test. On my calculator, this is the 5th option, so make sure to scroll down and choose one prop z test. From there, we want to find out what our p naught is, our x, and our n. All right, so let's take a moment to just figure out what our p-hat is. Our p-hat, which is made up of x over n, is from our test of our sample 250 and 225. They say they're unlikely to contract the Z-gum. So 225 over 250. And I like to figure this out so I can easily distinguish what my x and my n are. Alright, so my p naught is 0.85. My x is 225. And my n is 250. Alright, then I have to choose what kind of tell. Your HA always tells you what kind of tell. So you're going to choose the option that looks like not equal to your mean. Make sure that one's highlighted, then press calculate. Your answer is going to be P is equal to 0.0268261269. Now, the best way to go about it is to compare your P to your alpha. Let's round our P. 0.03. Let's compare our P and our alpha. Make sure P is always written first. Our P is 0.03 and our alpha is 0.05. The inequality that makes this true, it's a less than, right? 3 cents is less than 5 cents. So because it's a less than, our answer is to reject the null hypothesis. Reject. All right, so this is a highlight of every type of question you'll see on your exam. If you wish to practice more examples, here are the questions, what they are and where they're found in each section, and also what page. These problems are from the review questions at the end of each section. And also to help you out, I wrote down the commands for every problem, but you can also find them in your book. So your calculator functions are found for chapter 6. It's page 345. And for chapter 7, it's page 415. And that gives you a summary. It doesn't tell you, I'm not too sure if it tells you what to press, but it does give you a little screen and it shows you how it should look like. Alright, that's it. That's what you should expect for your exam. In addition, I might include some problems where I just ask you what's your claim, what's your null, your alternative, just so that you can, just to make sure that you're familiar with the reasoning for a hypothesis test. Alright, if you have any questions, feel free to email me or post them into our discussion board. Thanks.